this is our 10th Distinguished Lecture. So before I introduce our speaker here, I just wanted to recognize Mr. Kent, who's the person behind this series of the Distinguished Lecture, which we have it annually. It started in 2007, and Mr. Kent was a 1920 graduate of the University of Illinois in Civil Engineering. As a highway contractor and material supplier, he owned and operated two Champaign-based companies, which is General Paving and Builder Supply. Throughout his professional career, he expressed the highest regard for the education in the civil engineering at the University of Illinois. Actually, he is the founder of the University of Illinois Civil Engineering Alumni, which is considered the largest civil engineering alumni in the United States. He received 2 awards from here, which is the University of Illinois Loyal Award and the Civil Engineering Distinguished Alumnus Award. Actually, without his support, these events would not be happening. And now moving to our presentation and our speaker. Our speaker is Tom Scarpas. He's a very good and close friend. We have known each other for ages. And he graduated from 3 different countries, actually. His BS is from Canada, his master's from New Zealand, and his PhD from Delft University. His research, which many of you are aware of, is mostly on the consecutive modeling and the testing of pavement engineering materials, and recently has been working on the chemomechanics and of course he has been working on computational mechanics for a long period of time. He has been involved in many different organizations and taking leads on different committees in TRB, pt, ISAB, Rylands, and that's how we get to meet each other. And of course, we work together as the co-editors-in-chief for the International Journal of Pavement Engineering. So with that, please join me in welcoming Professor Scarpas, who's going to be talking about how are we going to make our skin softer? Will that make it? All right.
It's certainly a pleasure to be back. I'm sure it's an honor to be invited to give this particular lecture. Indeed, we have known each other for a long time, and somehow, you know, at the beginning when I started interacting with him, I was mad at him because I explained he stole one of my better candidates, but over the years he compensated for it. So, and well, all is well, I suppose. He also made the mistake to give me a free hand in choosing the topic. As he had said, I am a mechanics of materials person, but unfortunately what I found out is that nobody comes to us to buy an equation, unfortunately. People come to us to buy a solution. And that means that one has to come up with a model where you can bring your expertise to the industry, you have to interact with them in a way that they understand not your equation, but the value of your equation. Rejuvenation for us, and by us I mean Delft, where I work, but also for Europe, is a topic that we were drawn into by our industry, but also by the finances of Europe. Like many other parts of the world, Europe is undergoing this stage where we move, I was saying before, from design and construct to maintain. In a small country like Netherlands, we built every road we could think of. Now that we have them, they start aging on us. and we don't have the money to renew them. So somehow our industry, our authorities have moved into this direction, have moved into the direction of how can I maintain my infrastructure rather than replace it. And rejuvenation techniques provides that solution. Rejuvenation techniques also meant that as a group of road engineers, we had to step back, because a lot of these techniques do not imply I make something, I break it, and I sell it, but please help me to understand why is it better before I even make it. So a lot, as a group, we were led to smaller and smaller scales in the hope that somehow, if we work with the industry at that level, we could influence the deliverable, we could participate in the deliverable, we could learn, but also they could benefit from our expertise. So what I want to present is really an attempt to engage a whole sector of experts, always leading to a better product, a better paper. Very quickly, I wanted to show where I come from. This is an overall view of Delft University of Technology. We are the only technical university in Netherlands. It means engineering is only done in Delft. You can see the civil engineering building over here. You can see Rotterdam in the horizon. Netherlands is a small place. Before you get lost, you hit a boundary, you hit a border, and then you know it's time to come back. So you can see many cities from my office. We have a number of faculties. The faculties that a typical university, technical university will have. Civil engineering is an average size faculty. We are combined with geosciences, and we provide civil engineering education in Netherlands. Because we are a technical university, we operate at faculty level. We have a faculty of civil engineering, not a department, but we have departments within the faculty. And our department, I put it down here, the pavement engineering group, about estimate 5 academics and several PhDs, masters, postdocs, etc. To go back to how we got involved with rejuvenators, what our industry noticed is that because of many reasons, the quality of our pavement materials over time was degrading. And for those of you who are familiar with bitumen engineering or pavement engineering materials, degradation, among others, is indicated by a stiffening of the material. As time passes, the material becomes stiffer and stiffer, brittle and brittle. And that is not good for the final product, which is the road. So the question was, what do we do? We can build a new road, or we need another technique to rejuvenate that material. We need to talk to L'Oreal, or, ladies help me, one of these companies. Come on, another name?
Encom.
That one. And to tell us how to do it. I was explaining earlier that in one of the papers, as of this week in APT in Atlanta, has authors coming from one of the cosmetics industry, believe it or not. For that reason, they were driven back to chemistry. Go back. This is an indication of the stiffness of the bitumen while it was aged, or when it aged, and what we were asked to do, or what as an industry, and not only to speak to the university only, had to do is to say, how can we lower that response? How can we make the material again softer in terms of this plot? What can we do to move the stiffness of the material to another level? Literally, to make it new again. Think of dry skin and non-dry skin. at the average life of pavement, normally if you do nothing, it will tend to degrade, as I tried to show here in the sketch. As time passes, performance drops, because material properties degrade. One idea is to say, okay, every now and then I'm going to do something. I'll wait for a few years, and when my performance, whatever you choose to call performance, reaches a level, I'm going to do something. And in terms of the rejuvenation techniques, the name that you see in the industry is the in-service. So you have a pavement there, you don't go and remove the material. That's another thing. You have to try to do something to rejuvenate. When you put cream in your face, you don't take your face apart, you hope. You just... So the first level of techniques that I want to look at today at least is this. Techniques which allow you to really make the material new. How do you do it? Well, let's say you have some, on the local scale, you have two pieces of aggregate and some material in between, which, because of aging, because of punishment, can be because of the weather, can be because of environmental effects, whatever, it started going harder, it started cracking up, it started misbehaving, degrading. One possibility is to go and put something, a face cream. That's what it is. You apply it, hopefully not with a piece of cotton, but with a spreader. At night, so you don't disrupt the traffic, or on the weekend, less traffic. This thing tends to just stick there. Some of the techniques that are available have equipment following the spreader, which really blows air into this still warm new material in the hope that it drives it down into the pores, into the structure of the surface. And then perhaps, depending on what you choose to do, you may or you may not have some surfacing. Sometimes, for the beginning, the first few days, this is still a bituminous solution-like material. It's slippery. You may put some sand, you may put some other material on top. But the basic idea is this reddish area here, where somehow it shows that a new material has been placed on top of the existing bitumen in the hope that it will interact with the bitumen over there to improve it. You're not making a sandwich. You want the new material, the red material, to gradually infiltrate into the old stuff and rejuvenate it. And we'll see if and how it happens. The other technique is to say, well, for better or worse, my pavement is done. I was too late to do it early, or I'm rich enough to do it from the beginning today. But the material that is out there, the material which you can take as recycled asphalt now, to put it back, that's what we do, it's already degraded. If you just take it and put it back again, you haven't done very much. So, as another technique, yes, you can recycle the material that you feel is damaged, but that will not be enough. You will need to do something to that material, mix it with new bitumen. It's a solution. Maybe expensive. Mix it with something that will rejuvenate it in the mixer, we'll say, and will upgrade when you lay down again. It will give you almost as good performance, if not better. It's another technique. It presumes that you have already removed the material. You somehow made proper distinction of materials, proper division. It's not enough to just grind it off, mix it, and lay down again. You hope that you can do more sophisticated, and you can. You hope that somehow you have techniques, equipment that allow you to properly do this remixing process. It's not so simple as you say, but eventually it's It involves a removal at the end of service, a rejuvenation, probably in the plant over here, somehow, and then laying down again. And we'll see that there are techniques for that do this. As I said, we, in cooperation with our authorities, with our industry, we moved into this new domain for us. And our role was somehow to act as the bridge builders between the chemists, which belong to the industry, and who know a lot of information about the individual materials. They can control the quality at chemistry level, but at the end of the day, the chemist needs a guidance as to what he should go to do. He can mix many things and can come with many products, but at the end of the day, you need the pavement engineer at the end, you need the mechanics person at the end, to guide them into how, what is the objective. So you'll see that we spent a lot of time running several tests, most of them meant to guide us, to guide the chemists, onto where do we go? Do we choose this type of solution or that type of solution? This type of mix or that type of mix? I just made a list of the products that we had. The green column here, for those who can read it, shows 6 different Rejuvenator products. Sometimes we know what they're made of. Quite often I don't, because I don't ask. I don't see my role as getting the chemical recipe from the manufacturer. But I want to talk with him in terms of what controls the output of the chemistry. Because what you put into the chemistry will control my mechanical properties. Also, we had aged bitumen. We made them ourselves. Some of them later on, also other examples who came from field studies. But we wanted to somehow have the time and the effort to look at the mixing, the interaction of a range of rejuvenators. I only put a few here, but they're good. With a range of aged bitumens. Bitumens which somehow had, by oxidation, lost their original goodness, the original material properties. Remember what we said at the beginning, you don't just apply the cream and in the hope that it will just sit there. The purpose of the cream is to penetrate, to infiltrate. So the question we were faced is, does it happen? It's very difficult to look at the color. I painted red because it was easy, but when you look at it, it looks dark. And it's very difficult to say, does it happen, or is it just sitting there and acts as a skid, the limiter. So we started looking at nano-CT scans of samples, pictures like this, of samples which were without any application of rejuvenator, and that's a typical gray image that you will get out of the CT scanner. But then we started looking at various techniques. Remember in the first few transparencies I showed that in some cases there are products which are just sprayed and then you drive away. Others, after the spray, there is an air machine that applies pressure to drive the rejuvenator in. For one particular product that I showed here, you see the green areas is the areas where just because of the three-dimensionality and the large pore structure of that particular mix, there was some surface distribution of the rejuvenating material which was indeed applied on the surface by the spreader. Or the technique that also had or was applying air pressure after it was made corresponded to this sample, where now you see a much deeper penetration of the same product. So encouraging the rejuvenator to go deeper is good. Okay, we do it. This is a thin section view of what happens near the top over here. It's a small spot, you can see it, and the magnification is here. Forget the epoxy is for making the thin slice. What we're looking at is the stone, another stone here, the aged mortar, which is this darker reddish color in this picture, and then the added product, which was the rejuvenator. Okay, one good thing is that we plugged the hole. Because of weathering, some of the material, some of the bitumen is blown away. If we put something in, we plug the hole. Very simplistic, but it looks like it. And again, that's not what we started to do it for. But if you're interested in plugging holes, it works. This is the same picture. And I'd like to ask you to look at an area over here, for example, before and after rejuvenation. I can do it right. Yeah. This is the rejuvenator application. You see that now this area looks different than this one. See? But it's not only on top. If you look further down, you also see rejuvenator over here. See? So it does, if you do it properly, it doesn't just make a thin film on top. It can go further. It can help the aggregate structure a few centimeters from the top. Nice. Does it mix? Okay, back to the CT scanner. We put a jug, we took a bottle, and we put bitumen at the bottom and rejuvenator on top. So this grayish, yellowish object is the rejuvenator. It's a liquid. And this was the bitumen. And we just left it there for some time. 30 minutes, 180 degrees. And the end product, this one. We didn't stir it, we didn't do anything. We just watched it. Well, in reality, we were not watching it. The CT scanner was. Well, I suppose our student was there. And the CT scanner had better eyes than me because it could see much more. Same phenomenon. This is the interface, and bear with me. I don't know if you can see it from your place, but there is a change in grayscale below where I'm pointing, below where this arrow is. There is this area here, which is slightly grayer than the area above it. And in terms of the CT scanner's eyes, this line here is really this line here. And remember, this is just one-time shot. The phenomenon develops. What you get also free from the scanner is these colorful images as a measure of the grayness. Look what happens here. There is a gradual interface developing, which if you plot it sideways, it looks like this. The interface is here. So at very early time, and that's what this shows here, this pink here, you get this blue line here. But as time passes, it becomes the red line, the green line, and later on, if you wait long enough, you get pictures which more or less show the flat line. There's no interface anymore. The theory of mixing, hopefully it works, likely it works, allowed the two liquids, quote, to remix. That's what mixing theory. But it means that at the end of time, 90 minutes, I had one uniform density. I had another material. And if I have these curves, then I can start thinking in terms of calibrating the parameters of a diffusion model. The parameters of a model which, when I have, will allow me to play what-if scenario for many more parameters. It will allow my industry to decide, in their terms now, how to choose the new component, how to optimize, how to minimize, really, the time that it takes to go from the interface, the discrete interface, to the flat interface where you have a uniform density. Because the sooner it happens, the better it is. If you have to shut down the road for 3 weeks waiting for diffusion to occur, you don't have a product. If it can happen the same night, 90 minutes, next day it's usable. So one can produce diffusion models, if you wish, just by using the results from the CT scanner to help the selection of materials. That's what we started. For those of you who, so we have a rough model that the industry can use to choose the component. Nice. But for those of you who are into bitumen, will agree with me that many years ago, decades ago, people realized that there is no such thing as simple bitumen. The running joke we were making for many years is that it makes a difference if it comes from the tail or the nose of the dinosaur, but certainly it makes a difference geographically where it comes from. You find that you can use chemistry techniques to look in a more groupy way what is inside the bitumen. You can see some major, or you can decide to divide it, decide is the keyword, in primary groups. And if you look at different bitumen, coming from different destinations, origins, the percentages of the chemistry vary. And they can vary significantly. Compare this one to that one. No. So apparently, that chemistry will also affect my diffusion. When I was doing my diffusion, I looked at it as a homogeneous liquid, bitumen. Now somebody tells me, no, it's not. If you look very closely to that bitumen, it looks like this. It looks like a bunch of bees put together with something in between. These are real pictures. They're very small. This is 10 micrometers, I think. And that's what it looks like. So not only chemically it's different, it's got bits in it. And some of them mechanically are harder, bigger, stiffer, stronger than others. And all of them have to go and mix with the rejuvenator, who is also of a bituminous nature. So now you're going to have the bees of one fighting with the bees of the other to try to find a way to go across. Some of them will never make it. If you're not careful, you'll just sit there. Others may go very fast, but perhaps they have no use for you because they're very soft. They have no strength. If indeed my rejuvenator has the same sort of chemistry variations as my bitumen, then if I take it through the same chemical analysis, it will look the same, and we did. P3 here is one of our age bitumen.